a feeling for where it is. Yeah.
Pick a point
Just
where you
pick a point.
you can visually see that there
Yeah,
will be more
the more area, and then just find the
area.
area. So pick a point and find the area. So we know that when you're right here, when you're along when you're right there, what does the total area come out to be? So if it was, let's call that point A. If it was A, what's the total area? If it's halfway on the long side? If it's those segments are congruent, what was it? Do you remember? You don't have it in front of you? Anybody? Anybody?
Oh,
Wait.
Is it 1850? I think. I think it's 18.
I thought that was 10 away from
It's
the
1850 pi, right? What happens if it's here at B?
It's 2000.
Is it 17? Thanks, sorry. So it's 1750. And then what happens if it's at B? 2050 pi, right? So you've tested those points. Now what might be just a natural one to try to test? Yeah.
A corner.
Try the corner. Try the corner right in the middle and see what happens. We'll call that point C. So if you do it at point C, did anybody do it at point C? What do you get at point C, Kyle? 2,125 pi. So we automatically know that if you tether the cow at the corner, it'll be more than those other 2 points. Now, if you're going to test 2 more points, where might you test? And they're already kind of marked up there. What might you test? Yeah?
In between C and B and in between C.
Yeah, maybe call that point D and call that point E. Yeah. Did anybody do those points? Did anybody try them? Yeah, what do you get at point D? So at point D, what do you get? 2,000 what? 200. You get 2,200? Really? I don't think it's 2,200.
No, we did the 10. That's 10 from the corner.
We did.
We did in the
Oh! You know what? I'm sorry. I'm sorry. I labeled these wrong. I'm sorry. We did on our homework. Yesterday, it asked you 10 from the corner. I'm sorry, that's 10. We'll call the whole thing 40. But look, I'm sorry. So when we did this on our homework, what was D? D was 10 away from is right here. That was that 2050 or 1750?
It was 18.
It was 1850, right? I'm sorry, 1850 pi. And E, what was E?
2050.
2050 pi. I'm sorry, I labeled that correctly.
B was 2050.
No, B, it wasn't. Oh yeah, because it's halfway. The scale on this is just terrible, isn't it? Is it? No, it's 20. You're right. I'm just going crazy. And this is on recording. That's nice. 2050. Lovely.
Right.
2000. Yeah, the pen gets a little. So are we okay now? So on homework, we did D and B, right? They're 10 away, right? We didn't do mid. I'm sorry. So another point you could have tested was C, and someone already gave that to me. What was it? 2,125. Did someone agree? You guys pretty much agree with that? And then if you try A and E, did anybody try A and E? So this would be 5 away from there, and A would be 1,750 pi.
Do you know that E will be less than B?
Well, you don't know. You don't know that yet, unless we need more than that. We suspect it. Did anybody actually do E? It's 5 away from the corner. No, but you did this, and it looks like, from what you can tell, it looks like which one's the maximum. It kind of makes sense, I mean, logically, that as you move away from it, it might get higher or lower, but it looks like it's either just going to get lower or just going to get higher. It looks like it's getting lower no matter which way you go, but now we need to actually prove that. We need to actually prove that's true. Yes?
On my paper, I wrote that because the corner is the most, it's the most because it's not limited by edges as much as the center.
It's the least limited by edges. That's a good way to go about thinking about it. And that's why it should make kind of logical sense that that's going to be true. So let's do this. Let's write an equation, though. Let's write an equation. So I'm going to actually, let's say, I'm going to copy this. Actually, I'll just draw it again down here. Nice clean one. So if we take this and we draw another rectangle right here, and let's say that we'll put it right here. We'll call that point X. We'll call that this distance X right there. So this is 20 and this is 40. And we're going to come away with, so we know we go at 50. I'm going to make a bad arc. Woo. There's that. And then we know that this arc goes to like here-ish, right? And then this arc goes like that, correct? Is that did I do an okay job? Is that decent? So if that's X, and we'll call that point A right there. What's the radius? This radius is 50, right?
Yeah.
Do you agree with that? So what's the area of this half circle right here? Call that A1.
1,250.
A1 is going to be 1/2 of pi times the radius squared, right? 50 squared, correct? What's A2 going to be? It's going to be 1/4 of pi times the radius squared. What's the radius in this case? Nope. The radius is from here to there. We know that from here to here is 50, right? So what's the area from...
40.
No, it's not 40. It's in terms of x. It's what? 50 minus x. This distance from, let's call that b. Oh, let's use a different one. Let's use a different one for a. Let's call this, I don't know, q and r right there. What's the distance from q to r? X. What's the distance from r to s? R to s is our radius, and that's going to be 50 minus, because you know that you see these two green lengths? If you go from here to here, it's 50, but if you walk along here, it also has to be 50. So if this is x, what's the distance from here to here? 50 minus x. So this right here is the area of A2. What about A3? That's going to be 1/4 of pi times... yeah, because you get 50 minus 20 minus x squared. Because look, you have 50 minus x minus 20. What's 50 minus 20? 30. So if you add these three things together, the total area, and I think I'm recording, let's see here, yep, is going to be 1/2 pi times 50 squared plus 1/4 pi times 50 minus x squared plus 1/4 pi times 30 minus x squared. We still have a little bit left, don't we? Right? We still have a little bit left. We have this thing right here, correct? What's that radius going to be? If you take 50, if this is 50, right, and we move it over x, how much is this right here? 50 minus x, right? If that's 50 minus x, how much is over here? What's this distance right here?
X.
That's x, right? Because if it's here and you move this over x, how much is overhanging?
That's 40 minus x.
Why are you saying 40? This length from here to here is 50, right? 40 is the length from here to here. So if you have 50 from here to here, if you have 50 from here to here because you've moved it over x, how much is hanging over the edge?
50 plus
Close. Close. You guys are really close. You're not quite there yet. Who said it in back? What is this? Say it louder with confidence. This is a quadratic. Why do you know it's a quadratic? Yep. The highest power you have is x squared. Is there any way to get something other than x squared there? No. So theoretically, could you multiply this out and simplify it down into a quadratic?
Yes.
Absolutely. You absolutely could do that. If you have a quadratic, what's the shape of a quadratic? What's it called?
A parabola.
And the parabola either faces up or down. A parabola either has a max or a min. If you look at the parabola, right? If you're looking at the parabola. Okay, so theoretically you could look at this, but what did we say x was? X was between 0 and 10. So theoretically, could you graph this? Find the vertex? Could you graph a parabola?
Yeah.
Yes, you could. How could we use our calculator to solve this?
I have a question.
Wait, one sec. How could we use our calculator to solve this? If we wanted to find the maximum or minimum value of this equation,
100 points.
graph it and look. Yes, you can. That can help you find it. Okay. Let's say we changed it to a radius of 1/2. Circumference is 2 pi r, so that's going to be circumference is 2 pi times 1/2. So what's that? Pi. So let's look at a circle with radius 1/2. Let's look at a circle with radius 1/2. So we're looking at a circle with radius 1/2. So the idea here, what Luke is saying is, okay, draw the largest triangle possible that fits inside a circle with radius 1/2. If you graph this, so this graph is going to be on the x-axis. You're going to have number of sides, and on the y-axis you're going to have the area of that shape. The area of that shape. So how many sides does that triangle have? 3 sides. It'll come out to be some We can figure it out using some cool trig. We can find out some area. If you then took the same circle, radius of 1/2, and you drew inside it the largest square possible, it would be slightly more. And then if you did a pentagon and then a hexagon, septagon, you kept on going up, it's going to have more and more. But what you're going to end up with is you're going to end up with something that looks like this. It's always going to go up, but there's going to be a boundary. You add more and more sides into this, what Luke is saying is, so if you have this circle again, radius 1/2, and you do an n-gon, how close, if you find the perimeter of that n-gon, the perimeter of, how close is that to the actual circumference of the circle? It's very close. It's not quite there, but it's very close. And if we add in another side, does it get closer? Closer and closer and closer and closer. So what it does, it gets closer and closer, so it goes to n sides. It's going to get closer and closer to pi if you did this out. The question, though, is if you were going to do this, you need to know two things. First, what's the perimeter of an n-gon that fits inside a circle of radius 1/2? Is that necessarily going to be something easy for you to find out? No, you're going to need a trig for that. Amanda, go get some water. Now. But you can do that, and here's the thing. If you can get infinitely close to this, but you can't cross it, that is going to be the actual circumference. So once you prove that that's the actual circumference, you can come up with the formula. But the point is, if you go back to, ancient Greece, when people were first looking at this,